Welcome everyone. The question is, a body undergoes no change in volume. The Poisson ratio is, options are 0.5, 0.05, 0.25 and 2.5. Naturally, we basically let us consider it as a fixed support. So a wire is hanged somehow, okay. A force is applied on it like this way, maybe it is his own weight or whatever way it is. A force is acting downwards and due to it, its shape is deformed. When we are talking about the longitudinal stress and longitudinal strain, then we have considered that the change in the cross-sectional area, I am talking about this, the change in the cross-sectional area will be remain same. Okay, it is applicable when the cross-sectional area is very less than that of the length of the wire. Okay, but just think, a body is something like this. It have a definite cross-sectional area, and this cross-sectional area is comparable to that of the length. Okay, now somehow if by applying some deforming force you are able to change its length, then not only its length changed, but the cross-sectional area is also decreased to keep its volume constant. So we can say this is the change in its cross-sectional area and this is the increase in length. Okay, to keep the volume constant. Okay, so the cross-sectional area is decreased and the length is increased to keep this volume constant. So V is equal to constant. Since we have considered it is a cylindrical wire, so its volume is nothing but A multiplied by the length L. Multiplied by the length L equal to constant. Equal to constant. So just try to understand that. Now if I try to find out what is the change in volume, if it is, but since the volume is constant, it not should be. So you can say that volume's change is 0. That is the del V is 0. If the del V is 0, then we have to take del, that is the change in the area multiplied by that of the length, is equal to 0. Now just think that if small r is the radius, if small r is the radius of that cross section, then capital A is equal to pi r square. Okay. Now due to this extension or this deforming force, the cross section area capital A is decreased. That's why the radius is decreased from r to r minus del, we can say, and the length is increased to L to L plus del. Now if I replace this capital A by pi r square, then it will be pi r square into capital L is equal to constant. Now keeping this r and L constant, if I say the pi is a constant, it is changing. So if I consider this r and L constant, so r square into del into pi. Keeping this pi and r constant, the related term pi r square into del L, plus keeping this pi and L constant, we can say del of r square. Pi is itself a constant, so you cannot change pi, it is 3.14. So it becomes r square into capital L multiplied by 0. It is pi into r square multiplied by del L. It is pi multiplied by L. R square differentiation is 2 into r into del r is equal to 0. So it is completely 0. So I can take it on the other side, that is pi r square del L is equal to pi into capital L 2r del r with a negative sign, because I am taking this on the right hand side. This pi and this pi is completely cancels out. Now just think, in this expression, if I make this del L divided by L is equal to minus of 2 r del r divided by r square. Then this r and this one is cancels out. So this will become minus of 2 multiplied by del r by r. The Poisson ratio is defined as Poisson, Poisson ratio. Lateral strain, that it is talking about how the cross section area is changed, how the radius is changed with respect to that of the initial, divided by the longitudinal strain, that is how this length is changed with respect to that of the initial. So that will be del r divided by r, change in the radius divided by the initial, change in the length divided by initial. So if I replace these values here, that is del r by r, it will remain as it is. If I replace the value of del L by L, that is a longitudinal strain, that is minus of 2 del r divided by r. So del r by r and del r by r is cancels out. The Poisson ratio becomes minus of 1 by 2. Okay. If I take only the magnitude, then we can say it is 0.5 only. So the option A is the correct answer. Sigma, the Poisson ratio, is 0.5 in magnitude. Thank you very much.